Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 2. In this video, we're looking at Section 2.2 on properties of real numbers. The objectives of this section are to use the commutative and associative properties, use the distributive property, and finally use the identity and inverse properties. And I had a little bit of trouble deciding which student learning outcome this one fell under. So I just used the same one as the last section. It's not a perfect fit. All right, so we'll start with the commutative properties. I mentioned the commutative property in the last section because honestly, I forgot that it was not mentioned in Chapter 1. So anyway, now we'll make this official. The commutative properties basically say that when you add or multiply, the order does not excuse me, the order does not matter. And one thing that I hear from students, because you're going to hear a lot of these terms in this section, how do I remember which one means what? Well, one trick that I like to use is to think of a common word that this, mathematical term reminds me of. And for commutative, it's the word commute, as in, in the morning, you commute from home to work. At night, you commute from work to home, work, home, different order. Okay, that's what does it for me. All right, so here is an example of using the commutative properties. They want us to use a commutative property to complete each statement. First one is -2 times x is equal to what? So remember, the commutative property of multiplication says that you can multiply two numbers in whichever order you want. So that would mean that -2 times x is the same thing as x times -2. And I just want to point out that I've written this in a slightly unusual way. Normally, we don't put a multiplication sign right next to a negative sign because it makes it kind of hard to read. So I would recommend writing that expression like this. All right, next, 19 plus 3y is equal to what? So this expression is a sum. It's the addition of two terms. So using the commutative property of addition, 19 plus 3y is equal to 3y plus 19. All right. Next, we have the associative properties. All right, and again, we have them for addition and multiplication. Associative properties have to do with grouping. So for example, with addition, it says that if you're adding the numbers A, B, and C, it doesn't matter if you add A and B first and then add C, or if you add B and C first and then add A. And the same thing for multiplication. If you're multiplying A times B times C, you can multiply A times B first and then multiply by C, or multiply B times C and multiply that product by A. These properties come in handy a lot for doing arithmetic in your head. And maybe I'll show you an example when I switch over to my tablet. I just thought of that just now. I don't have one ready right this second. To remember the associative property, remember the word associate, as in the people you associate with. Maybe you have two best friends, and sometimes you hang out with one of your friends, but not the other, and sometimes they hang out without you, and it's all good. All right, so a similar example to the last one, we're going to use now an associative property to complete each statement. So it may be helpful to remember that the associative properties have to do with just moving parentheses. We're not changing the order of the terms. So for example, the sum of y plus 4 and then add z, is the same thing as y plus the sum of 4 and z. So notice that the terms y, 4, and z are kept in the same order. It's just which two numbers we're adding first. For multiplication, the product of negative 3y and z, if we move the parentheses, is the same thing as the product of negative 3 and y times z. All right, and now I am going to switch over to my tablet and show you this example. We're going to use the commutative and associative properties to simplify this expression, the sum of 7 and x plus 4. So switching over to my tablet, which you'll see me doing quite a bit in these videos. All right, so what I really want to do is get the 7 and the 4 next to each other so that I can add them together. So one way to do that is to first use the commutative property to change the order of the x and the 4. So instead of x plus 4, we'll write 4 plus x. Okay. Now, again, I want to add that 7 and 4 together, but I can't do that as long as the parentheses are around 4 plus x. So now I'm going to use my associative property to move the parentheses to be around 7 plus 4. All right, and then finally, this is not using a property. This is just adding 7 plus 4, which is 11. The simplified form of this expression is 11 plus x. If you want to, you don't have to, but you can also write that answer as x plus 11 because, of course, addition is commutative. So these are the same answer. All right, either one is just as good as the other. All right, so now let's switch back to the presentation and talk about the distributive property of multiplication over addition, or we just usually call this the distributive property. All right, the distributive property says that if you multiply A times B plus C, and you've probably seen this before. I think every instructor I've ever watched do this will draw these little arrows to kind of help you keep track of what's going where. All right, that is the same thing as A times B plus A times C. And this is a very helpful property for simplifying expressions that have both numbers and variables in them. All right, little meme I cooked up a few years ago. I enjoy that meme. All right, so let's get rid of this now. We're back to examples. We're going to use the distributive property to write each expression without parentheses and then simplify the result. And I believe I'm doing all these examples on the tablet. So we have 4 examples of using the distributive property to rewrite the expression and then simplify the result. And then we're going to use the distributive property to write each sum as a product. So that'll be the last 2 examples. All right, back to the tablet. And here we go. So the first one is 3 times 8x minus 1. So remember, we're going to distribute the 3, which gives us 3 times 8x minus 3 times 1. 3 times 8 is 24. So 24x minus 3. And remember, 24x minus 3 is in simplest form. Don't try to make that 21x or anything else. 24x minus 3 is as simple as that gets. All right, next, we have negative 4 times 4 plus 2p plus 5q. All right, now I am going to show a ridiculous amount of work to start off with, but then later on, if you want to skip some of these steps, it's fine. Just be careful about skipping steps because I find that's where people make mistakes. I used to make a lot more mistakes when I would skip steps. All right, so first we have -4 times 4, which is -16, plus -4 times 2p, which is -8p, plus -4 times 5q, which is -20q. All right, now we don't need to leave that expression like that. Remember from our chapter 1 review that adding the opposite of 8p is the same thing as subtracting 8p. And the same thing for adding the opposite of 20q, that's the same thing as subtracting 20q. So the simplest way to write this is -16 minus 8p minus 20q. And I want to point out that in this expression here, every single term had a plus. Even this one, you can think of there being an invisible plus there. After I distributed the negative number, every single term had a minus in front of it. And that is always the way it works. When you distribute a negative number, it changes all the signs. Okay, good thing to remember. Next, -1/5 times 10a minus 25b. All right, so people always get nervous when I throw fractions into the mix. Okay, but the fractions are not that bad, especially in this problem. We have -1/5 times 10a. All right, and now I'm going to use my shortcut. Instead of writing minus negative something or other, I'm just going to remember what I just told you about distributing a negative number changes all the signs. So instead of plus minus, it's going to be minus plus. So we'll make this +1/5 times 25b. All right. Now, here's a suggestion. When you multiply a number times a fraction, a lot of people find it helpful to sneak a 1 under the whole number. And then we can take out our common factor, which is 5. 5 divided by 5 is 1. 10 divided by 5 is 2. 5 divided by 5 is 1. 25 divided by 5 is 5. So my final answer is going to be -2a plus 5b, which looks a whole lot nicer than what I started with. That's why we call it simplifying. All right, and finally, we have -6 times 2x plus 1, and then we're going to subtract 1. So notice that -1 is outside the parentheses, which means the -6 does not get distributed there. This is just going to go -6 times 2x. And now I'll just write this as -6 times 1 and then -1. -6 times 2x is -12x. -6 times 1 is -6. All right, and the last thing I'm going to do is combine the like terms. -6 minus 1 is -7, right? All right, and that takes care of that batch of examples. Okay, now we're on to a new batch of examples. Remember that the directions for this one said write each sum as a product using the distributive property. So what we're going to do in this example is run the distributive property backwards. Okay. So in this first example, we have 14 times z plus 14 times 5. So the idea there is that we started out with a 14 outside parentheses. And what was the other piece? Well, there was a z here and a 5 over here. Okay. If you find it difficult to think in that direction, it is maybe a little bit harder, but it is very easy to check the answer, right? If you just put your little arrows over top here, you can see that that gives you the right thing. 14 times z, 14 times 5. So this is the answer they want. Same exact thing in letter B, they just left out the multiplication dot. 25 is being distributed over x plus y. That's it. 25 times x is 25x. 25 times y is 25y. Oh, a little bit off topic, but I didn't want to forget. So when we were talking about the associative properties, I mentioned that they're very helpful for doing arithmetic in your head. So for example, let's say that you wanted to add, I am cooking up this example off the top of my head. Give me just a second here. Okay, let's say you're trying to add 19 plus 47 plus 3. All right, and you've left your phone in the other room, so you don't have a calculator. Most people's inclination, especially if they're doing it on the calculator, is to just add from left to right. The problem is 19 plus 47. I mean, you can all add that, but you might feel like you need to grab a piece of paper. Well, this is where the associative property comes in handy. Instead of adding 19 plus 47, do 47 plus 3 first, which is easy to do in your head. And then 19 plus 50, also easy to do in your head, is 69. The same kind of thing works with multiplication. So for example, let's say you're doing 17 times 25 times 4. All right. 17 times 25 is very difficult to do in your head, but 25 times 4 is easy to do in your head. And 17 times 100 is easy to do in your head, right? Okay, so you can actually use these associative properties outside of just doing algebra. All right, and we talk a lot about that in a class that I teach pretty frequently, Math 20A, which is math for future elementary school teachers. It has a different name, basic structure of math or something like that, but I always call it math for teachers. All right. So if you're thinking about being a teacher, you could take that class. It's a fun class. You don't even have to want to be a teacher to take it. I do sometimes see people from other majors in there. It satisfies, general math requirements. All right, commercial over. Last set of properties, the identity and inverse properties. All right, addition and multiplication both have what are called identity elements. These are numbers that don't change the answer. So now again, how are you going to remember these? Well, when you think about identity, maybe you think about your identity. You don't change your identity, right? And so these numbers are numbers that will not change who you are, right? Who the number is. All right. So for addition, that number is 0. A plus 0 is equal to A. Any number plus 0 is itself. And that also works in the other order. And for multiplication, that special number is 1. Any number times 1 is itself. And 1 times any number is itself. All right, and then you have the inverse properties. So these are numbers that will give you the identity element as an answer. All right, so what I sometimes say about the inverse properties is that another way to describe the inverse properties is to say that opposites and reciprocals are a thing. All right, every number has what's called an opposite. When you add a number and its opposite, you get 0. And every number except 0, I should have written that in here, a does not equal 0. Every number except 0 has what's called a reciprocal. When you multiply a number times its reciprocal, you get 1, which is the identity element for multiplication. All right, so now we're going to throw all of those properties together, and we're going to try to name which property is illustrated by the statement, starting with 4 times 3 plus 8 is equal to 4 times 3 plus 4 times 8. So out of all the properties we've talked about, commutative, associative, distributive, identity, and inverse, which property is that? That is the distributive property, right? Next, 1 times 9 equals 9. All right, what is that property called? I see 9 being multiplied by a number, and I'm getting 9 as the answer. The number did not change, just like you don't want your identity to change, right? So this is the identity property of multiplication. Next, we have 6 times 1 over 6 equals 1. So a number and its reciprocal. Another word for reciprocal is inverse. This is the inverse property of multiplication. Okay, next example. The sum of a plus 9 and 6 is the same thing as the sum of a and 9 plus 6. So the only difference between those two expressions is that I have moved the parentheses. What's that called? That's called the associative property of addition. All right, now here I am maybe being a little sneaky. The sum of 11 plus r and 8 is the same thing as the sum of r plus 11 and 8. Is that also the associative property? It kind of looks like a very similar example, doesn't it? Well, I did that on purpose. This is actually not the associative property. This is the commutative property, because the only difference between those two expressions is that in one of them, it's 11 plus r, and in the other one, it's r plus 11. So that is not associative property. That is commutative property. And that's going to do it for section 2.2. We'll see you next time.